So we're going to be looking at another form of factorising today, and this is called the difference of two squares. So before we get into it, we need to know and understand square numbers. So we're going to begin just by recapping what square numbers are. So here we've got 9 dots and they've been arranged into a square. And that is why 9 is called a square number, because it can be arranged, into a perfect square. So we would say that 3 squared, because 3 times 3, so we've got 3 columns by 3 rows equals 9. And it's also written, this is how it's written, 3 and then with a little 2 up the top. So 3 squared equals 9. So that means 3 times 3. And so squaring numbers means multiplying it by itself. So take any number, multiply it by itself, and you will get a square number. Now, if you were working in reverse, so let's say we were trying to find what the square root of 9 is. So the opposite of squaring something is called the square root. So if you were asked, the square root of 9 is 3, we're thinking, what times is by itself to give us 9? And it can be written with this little symbol here. So the square root of 9 equals 3. So we're really needing to focus on our square numbers, and it is really important that these square numbers you must know and memorise. So here are the first 12 square numbers. Okay, so these numbers you should be able to easily identify, be able to spot and know that those are square numbers. So for instance, 1 is 1 squared, so 1 times 1. 4 is 2 squared, 2 times 2. 3 squared is 9, and so on, all the way up to at least 12 squared. So 12 times 12 is 144. Okay, but just looking at these numbers, you should be able to identify them as squared numbers. Okay, so I'd probably pause the video here and note all these down somewhere so you can refer back to them easily and just begin to become familiar with them and memorise them so you can easily identify them. Okay, so first task for you, once you have, I would probably take a couple of minutes or so to memorise these for a bit if you're not 100% sure on them. And a little task for you is just all about identifying square numbers. In each set of 3 numbers, find the one which is not a square number. So we've got 4 sets, but each one's got 3 numbers in it. In each of these sets, I want you to identify the number that is not a square number. So if you pause the video here. Okay, let's go over the answers. So for the first set, 4 is a square number because 2 times 2 gives you 4. 15 is not a square number. There's not a number that multiplies by itself to give you 15. So that is the odd one out, because 25, 5 times 5 gives you 25. Second set, 9, 3 times 3 gives us 9, so that's a square number. 16, 4 times 4 gives us 16, so that's a square number. However, 35 is not. Third set, 25, we know it's 5 times 5. 49, 7 times 7. 56 is the odd one out here. And for the last one, 2, there's no number that multiplies together to give you 2. 8 times 8 gives you 64. 10 times 10 gives you 100. Therefore, 2 is the odd one out. So well done if you got them correct. Okay, now we have looked at a little recap of square numbers. We are going to start looking at the difference of two squares and how we use this to factorise. So if we remember that factorising is essentially the opposite of expanding brackets, we're wanting to put the brackets back in. So let's say we considered expanding this double bracket, okay, and we're going to be using the method where we're multiplying the first term with every term in the last bracket, and then the second term with every term on the last bracket. So if we do that, x times x gives us x squared. And then x times negative 2 gives you negative 2x. 2 times x gives us plus 2x. And then 2 times negative 2 gives us negative 4. And once we've done that, we need to always remember to collect like terms. So collecting like terms, the middle terms will, so negative 2x, add 2x, they're going to cancel each other out, and we're just going to be left with x squared subtract 4. Okay, and this here, these are the type of expressions that we are going to be factorising today. So we're going to be putting them back into these double brackets. Okay, so in reverse, when we factorise, we're going to be taking something of this form and putting it back into these original brackets. And notice where the name difference of two squares come from. So the difference, because it's a subtract, okay, you can only ever use this method if there is a subtract in between the two terms. And the first term, so it's difference of two squares, x squared, remember this means x times x, so technically x is a squared term, and then 4 is a squared number. So we've got a difference of these two squares. So an algebraic expression of this form, okay, a difference, and then these two terms need to be square numbers or square terms, is known as a difference of two squares, where both the terms x, well, in this example, both the terms x squared and 4 are squares, and there is a subtract in the middle. Okay, let's work through some examples. So the first one, we are being asked to factorise y squared subtract 25. Before we do anything, yes, we are working on difference of two squares, but let's just keep referring back to what this actually means and how we know that we can use this method. Well, we've got a difference, so it needs to be a subtract. You cannot do it with an add. We've got our first term as a squared term, which is good, and 25. I've identified that as a squared number, so now I can go ahead and do the difference of two squares. So the first thing we're going to do is we're going to find the square root of each of these terms. So the square root of y squared, is y, because y times y gives you y squared. And then the square root of 25 is 5. So those are our two square roots of the two terms here. Once we've done that, we're going to start putting into our brackets. So if you draw out your two brackets, and the square root of the first term goes at the start of each of your brackets, and the square root of your last term goes at the end of both your brackets. And the final step is you need to put in the plus and negative sign. And it doesn't matter where you put them inside the bracket, they just need to be two different signs. So you could have put the negative here and the plus here, vice versa. And that is your final answer. And remember, you can always double check and multiply these out. And once you multiply it out, you definitely should get back to y squared subtract 25. And that's when you know you've got the right answer. Okay, so with that example, following it carefully, can you please pause the video here and give this one a go? Okay, hopefully you've unpaused now. So we're going to be looking at the difference of these two square terms. So we're going to find the square roots of each of those terms, so x and 10, because 10 times 10 gives you 100. Then we're going to put it into brackets, so we're going to draw our brackets out. The square root of the first term goes at the start of the bracket, the square root of the second term goes at the end of the bracket, and then you're just going to fill it in with the plus and negative sign. So well done if you got that. Okay, second example. This time we're factoring 64 subtract x squared. Notice that our algebra term, our letter term, is the second term in the expression, but we're still going to follow the same steps. So we are going to identify this square root of 64, which is 8, because 8 times 8 gives you 64, and the square root of x squared is x. So we're going to set out our brackets. The square root of the first term needs to go at the start of the bracket, the square root of the second term at the end, and then we just stick in our plus and our negative sign. And like I said, it doesn't matter what way around the signs are. So technically, if you had the answer where the negative was at the start and the plus was at the second bracket, it doesn't matter which way they go. Okay, so using this example again, can you please factorise this expression? 36 subtract x squared. Okay, so answer to this one. Square root of 36 is 6, and then the square root of x squared is x. So set out your brackets. Square root of 36 goes at the start of the bracket, and then square root of x squared goes at the end. And your plus and your negative sign. And that's your answer. So well done if you got that. Okay, third example. This one a little bit trickier. So 25a squared subtract 36 we're going to factorise. Notice here that we've got a number in front of our algebra term. As long as this number here is also a squared number, we can just still follow the same steps. So this time what we're going to do is we're going to find the square root of 25, which is 5, and the square root of a squared, which is a. So our first term in our brackets is going to be 5a, okay, because 5a times 5a will give you 25a. So think of it like square root in the number and then square root in the letter. And the square root of the first term goes at the start of the bracket, and then we know the square root of 36 is 6, so it goes at the end. And then we're filling it in with our plus and our negative, or whatever way around you put it. Okay, so like I say, as long as this number in front of your squared term is a square number, then just follow the same steps. Okay, so can you please, again, pause in the video and give this one a go. Okay, so answer to this one. As long as the number in front of your algebra term is a square number, we can follow the same steps. So the square root of 49 is 7, square root of b squared is b, and then the square root of 16 is 4. So the square root of the first term goes at the start of the bracket, so we've got 7b and 7b, because 7b times 7b will give us 49b squared. Square root of 16 goes at the end of our brackets, and then adding in your plus and your negative signs. So really well done if you got that. Okay, a last example before I ask you to try some questions. It's just a little reminder example that 1 is a square number, okay? So always remember that 1 is a square number. 1 times 1 equals 1. So we can use the difference of two squares with this expression here. Just following the same steps, that square root of the first term is x, and then because the square root of 1 is 1, 1 goes in both of these brackets. And if you're ever unsure about anything, multiply the brackets out and you should get back to this original expression. Okay, if you could pause the video here and try these 6 questions. I would say these last two ones are a little bit more challenging because there's an algebra term in the second term of the expression, but still apply the same rules. I'm sure you will manage, but give them a go and pause here. Okay, let's go through the answers. So the first one, you should have x plus 9, x subtract 9, or the other way around, x subtract 9, x plus 9. Second one, you should have 7 plus y, 7 minus y. Next one, 4 subtract 5y, or 4 add 5y, 4 subtract 5y. And the fourth one, 3c plus 4, 3c subtract 4. And question 5, so the square root of the first term is just e, and the square root of the second term is 7f. So you should have e plus 7f, then e subtract 7f. And the last one was definitely a lot trickier, but really well done if you got this one. You should have 9x plus 5y, and then 9x subtract 5y. These questions are really about, it definitely looks tricky, but if you break down this term, square root this term, put it at the start of your brackets, and then just focus on the second term, square rooting that, putting it at the end of your brackets, and then just filling in your plus and your minus signs. Really well done if you managed well with those. Okay, a couple more examples, and again, progressively getting a little bit trickier. So this example, is clearly not a difference of two squares because we know that 2 is not a square number and 18 is also not a square number. But as we're just learning all about factorising, the very first kind of factorising we learned about was factorising using a common factor. Okay, and no matter what kind of factorising it looks like, you must always start factorising by looking for a common factor. No matter if you straight away think you know what you need to do, just look for a common factor to be sure. So here we can see that there is a common factor of 2. And we're going to take, just using your previous knowledge of factorising with a common factor with this. So if you were just going to factorise this using a common factor, we would take out 2 on the outside of our brackets, 2 times, and then fill in your brackets. 2 times x squared will give us the first term, and then 2 times 9 will give us the second term. And now notice that inside the brackets, we have a difference of 2 squares. So when we are factorising, we are always fully factorising. So we need to check inside our brackets to see, can we factorise this any further? And in fact, we can. And when we go to do that, we need to write 2 at the start of, because we're going to write out our double brackets, but the 2 needs to be right at the start. We can't forget that. And then just factorise using the difference of 2 squares as you normally would. So x squared, x goes at the start, square root of 9, 3 goes at the end, and then adding in your signs, your different signs. And like I say, your common factor term must go just at the very start of both your brackets. Okay, if you could, again, follow in this example really carefully, can you factorise this? Okay, hopefully you've unpaused. Let's go over the answer. So like I say, always looking for a common factor first. The common factor here is 3. So we're going to take 3 outside of the brackets. 3 times x squared gives you 3x squared. 3 times 4 gives you 12. And now notice inside the brackets we have a difference, because it's a subtract, of 2 squares. So keeping that 3, the common factor at the very start, you can fill in your brackets. So x and then 2 plus and minus. Really well done if you got that. These are quite tricky. Okay, so another example. Just our different from here. We've got our number term is going to be coming first. Okay, but again, it just following the same steps. Again, it doesn't look like a difference of 2 squares, but no matter what kind of factorising it is, we always look for a common factor. So our common factor is 5. Take 5 outside of the bracket. 5 times what gives you 5? Well, 5 times 1. 5 times what gives you 45x squared? Well, 5 times 9 gives you 45, and then we need that x squared on the end. And now we have a difference of 2 squared, because remember, 1 is a squared number, and so is 9. So keeping that common factor at the start of our 2 brackets, we've got square root of 1 is 1, so that's at the start. Square root of 9x squared is 3x, so that's your second term, and then filling in with your signs. So pausing the video whenever you're ready to do so, and can you please factorise this one? Okay, let's go over the answer. Hopefully you've managed to unpause this now. Always look for a common factor first. And always think as well, if they're both even numbers, there will always be a common factor of 2 if you need somewhere to get started. In this case, the common factor is 2. So we're going to take 2 outside of the brackets. 2 times 1 gives us 2. 2 times 100x squared gives us 200x squares. And now we have a difference of 2 squares. So keeping that common factor there, and then we've got our 2 brackets. Square root of 1 is 1. Square root of 100x squared is 10x, plus and minus. If you forget to put that common factor, if you forget to carry that common factor down, you definitely risk losing marks, okay? So be really careful there. Okay, so again, I'm going to ask you to try these questions. Some questions to watch out for, definitely the last three, okay? But remember, although these look really quite tricky with the cube terms, look for a common factor first, and hopefully the factorising with the difference of two squares should fall into place. So if you pause now and give these a go. Okay, let's go over the answers. So 2x squared subtract 8. We're going to take a common factor of 2 outside, so you should have had 2 and then bracket x squared subtract 4, leaving 2 as your common factor and then the square root of x squared and the square root of 4 to get this first answer. Second one, you've got a common factor of 2 again, and then you would have been left with 2 and then 25 subtract y squared. That's where these numbers come from. Third one, a common factor of 3. So take 3 outside of the bracket, leaving your 9 subtract a squared. And then you just need to factorise that bracket using the difference of two squares. Okay, this one, your common factor was 4. And once you've taken that out, you would have been left with x squared subtract 25y squared. And then the square root of x squared is x, square root of 25 squared is 5y. Question 5, okay, we've got a cube term there, but we're going to look for a common factor first. So our common factor in this case is in fact x. So we're going to take x outside of the bracket. That would have left us x squared subtract 49. Then the square root of x squared is x, square root of 49 is 7. And our last one, our common factor was a, leaving x squared subtract y squared, and that's where these square root terms come from. So if you at least got the first three correct, really, really well done. If you managed the last three, they were really challenging. So excellent work if you got any of those correct, if not all of them. Well done.